and we see that a lot in a lot of different applications. And of an angle, both even and odd angles. Here we're going to do the sine. We'll start with the odd angle, and then we'll do the even angle after that. Odd angle, the number leaves equals the number from the angle. So this would be 1 leaf, this would be 3 leaves, and this would be 5 leaves. Also, with the co-direction axis, but in the sine, it'll depend upon what the equation looks like. In this case, the way you find the first leaf is you take 90 degrees and divide by the number. Welcome to Lecture Online, and here's our third video on how to draw roses. Roses is one of those peculiar forms in polar coordinates, and we start graphing a lot of different applications. Let's go ahead and do this one as well. Now, in the previous two, we dealt with the cosine of an angle, both even and odd angles. Here we're going to do the sine. We'll start with the odd angle, and then we'll do the even angle after that. Remember, with the odd angle, the number leaves equals the number from the angle. So this would be 1 leaf, this would be 3 leaves, and this would be 5 leaves. Also, with the cosine, the first leaf always starts on the horizontal positive x direction axis, but in the sine, it'll depend upon what the equation looks like. In this case, the way you find the first leaf is you take 90 degrees and divide by the number in front of the angle, which is 1, which means that the first leaf starts at an angle of 90 degrees, which is in this direction right here. In that particular case, the first leaf starts at an angle of 90 degrees, which is in this direction right here. In that particular case, the first leaf starts at 90 degrees divided by the number in front of the angle, which is 3, which is at an angle of 30 degrees. So if we go up 30 degrees, like that, this is the axis about which the first leaf will form. And of course, since there's 3 leaves, and then they're situated at an equal distance away from each other in terms of angle, at an equal angle away from each other, you can then find that the other 2 can be found by taking 360 degrees. Let's take 360 degrees divided by 3, which is 120 degrees. That means that every 120 degrees, you will find the leaf. So at 120 degrees, at 150 degrees, so it would be in this direction right here. So it would be at 150 degrees, at 120 degrees to that would be right here, at 270 degrees. So those would be the 3 locations where the 3 leaves are found. So at 30, at 150, and at 270. Let me put 30 degrees down right there. So that's how we find the location of the leaves. In the 5-leaf rows, the first leaf is going to be found by taking 90 degrees divided by the number in front of the angle, which is 5. So 5 goes into 90. That would be 18. That would be 18 degrees, wouldn't it? 5 times 18 is 90. So that means the first leaf would be found at an angle of 18 degrees. Now, where are the other leaves? Well, there'll be 5 leaves. They're spaced apart in equal angles. So we take 360 degrees and divide it by 5. And what do we get? 5 times 360. I better make sure I get this right. Divided by 5 equals 72 degrees. That's right. So every 72 degrees, so add 72 to 19. That gives you 90 degrees. So there'll be a second leaf at 90 degrees. A third leaf would be 90 plus 72. That's 162 degrees. That would be right about there. 162 degrees. Add 72 to that. That would be 234 degrees. 234, that would put us right about here. And add 72 to that, that would be 306 degrees. That would be right about here. And so we have 1, 2, 3, 4, and 5 leaves, all evenly spaced, 72 degrees away from each other, starting at 18 degrees. So that's how you determine how to graph these. Now the rest would be relatively simple. With a 1-leaf rows starting at the top right here, so 1, 2, 3 units away, because we have 360. So add 72 to 19, that gives you 90 degrees, so there'll be a second leaf at 90 degrees. A third leaf would be 90 plus 72, that's 162 degrees. That would be right about there, 162 degrees. Add 72 to that, that would be 234 degrees. 234, that would put us right about here. And add 72 to that, that would be 306 degrees. That would be right about here. And so we have 1, 2, 3, 4, and 5 leaves, all evenly spaced, 72 degrees away from each other, starting at 18 degrees. So that's how you determine how to graph these. Now the rest would be relatively simple. With a 1-leaf rows starting at the top right here, so 1, 2, 3 units away, because we have 3 right there. So this would simply look like a circle, just like that. The 3-leaf is a little nicer like that. So we start at the first one over here. So 1, 2, 3, start right there. So we go like this, we go like this, then we drop like this, and we come back around like this. And there's your 3-leaf rows for the r equals 3 sine of 3 theta. Of course, again, the number 3 in front simply determines how big each leaf is, how long each leaf is. All right, for the 5-leaf, remember we start at 18 degrees, 1, 2, 3 units. So go like this, then we come this way, then we come this way, and this way, and finally we complete this one right there. And there's your 5-leaf rows. Again, all line should go exactly to the origin right there, and this one is a little bit out of shape, but hey, not bad for hand-drawn one. And that's how we go ahead and draw the odd functions, the 1 theta, 3 theta, 5 theta for the sine. Notice the first one starts at 90 degrees divided by the number in front of the angle, so it starts at 90. 9 divided by 3 is at 30 degrees, 9 degrees divided by 5 is 18 degrees, and then you space them out according to taking the 360 degrees divided by the number you have here, because that's how you have to divide the space in angle between the number of leaves you're going to draw. And that's how we draw the odd functions. Now in the next video we'll draw the even functions to see how you do those.
Work is a pain in the ass.
Welcome back. In this video, you'll learn how to graph polar equations. Let's get to it. All right, so in the last 2 lessons, you were introduced to polar coordinates and polar equations and how to convert them into their rectangular counterparts. But now what we're going to do is kind of put those concepts together and look at polar graphs. Because polar graphs are the result of being able to sketch polar equations, which we can do with the help of polar coordinates. And so remember that polar equations are typically in this form right here. We have r is equal to some function of theta, and for a given value of theta, we can output a particular value of r that will give us our polar coordinates of r comma theta. Plotting different pairs of polar coordinates from a polar equation is going to result in points that we can connect to sketch the graph of a polar equation. And now, just as a little refresher, here are some examples of some polar equations. You can have an equation where you just have r equal to some constant. You could also have an equation where you just have theta equal to some
includes circles, limacons, rose curves, and lemniscates. So let's start with a circle. The first equation you may see is r is equal to a cosine theta. In this video, we're going to talk about how to graph polar equations. These include circles, limacons, rose curves, and lemniscates. So let's start with a circle. The first equation you may see is r is equal to a cosine theta. Now, if a is positive, this is going to be a circle directed towards the right. Now, granted, my circle is not perfect, so bear with me. A is basically the diameter of the circle. And this is going to be the center of the circle, so if you go up to find this point here, it's half of A. So if A is greater than 0, if A is positive, it's going to open towards the right. And if A is negative, you're going to get a circle. Let me draw a good looking circle this time. You're going to get a circle that is directed on the left. So keep in mind, this is going to be A, and this is half of A. So let's try some examples. And let's say if we have the graph R is equal to 4 cosine theta. If you want to, feel free to pause the video and try it yourself. So we're going to have a circle on the right side. Now A is 4, and half of A, well, 4 divided by 2 is 2, so that's half of A. So what we're going to do is travel 4 units to the right, and then up 2 units, and down 2 units. So the circle is going to start at the origin, and it ends at 4 on the x-axis. From the center, which is at 2, we need to go up 2 units and down 2 units. And then simply just connect it. So that's how you can graph R equals 4 cosine theta. Let's try another one. Try this one. Let's say that R is equal to negative 6 sine theta. I mean, not sine, but cosine theta. We can get into sine later. Now, because A is negative, we get into negative sine theta. Now, because A is negative, the circle is going to be on the left side on the x-axis. So let's travel 6 units to the right. Since A is negative 6, 1/2 of A is negative 3. Now, don't worry about the negative sign too much. The negative sign just tells you if the circle opens to the left. Now, the center is going to be at negative 3, which is here. So we need to go up 3 units and down 3 units. So the graph is going to be at the origin at negative 6, at negative 3, 3, and at negative 3, negative 3. And so that's how you can plot the circle. So keep in mind, this is equal to A, that distance, and this is also equal to A as well, which means this part is 1/2 of A. So half of A is basically the radius of the circle. So if for some reason you need to find the area of the circle, you can use this equation, pi r squared. The radius is 3, so it's pi times 3 squared, which is 9 pi. So now, the next formula you need to know is R equals A sine theta. Cosine is associated with the x values. So as you can see, the circle was associated with the x-axis. Sine is associated with the y values. And so the next formula you need to know is R equals A sine theta. Cosine is associated with the x values. So as you can see, the circle was associated with the x-axis. Sine is associated with the y values. And so the circle is going to be centered on the y-axis. So let's say if A is positive, then we're going to have a circle that goes above the x-axis, centered on the y-axis. So once again, the diameter will still be equal to A. And this portion, the radius, is half of A. So that's when A is positive, or when A is greater than 0. Now in the other case, if A is negative, or if A is less than 0, the circle is still going to be centered around the y-axis, but it's going to open in a negative y direction. So it's going to be below the x-axis. And so the radius, as you mentioned before, is just 1/2 of A. And the diameter is equal to A. So let's try some examples. Let's say if R is 2 sine theta. Go ahead and graph that. So first, we need to travel up 2 units. A is 2. Half of A, which is the radius, is 1. So we're going to have these 2 points. Now let's travel 1 unit to the right and 1 unit to the left. So the green dot is the center of the circle. So we're going to travel 1 unit to the right and 1 unit to the left from it. And so this is going to be the graph. Try this one. Let's say r is negative 8 sine theta. Go ahead and work on that example. Now the majority of the graph will be below the x-axis. I'm going to focus on that. So let's travel 8 units down.
Mình đã 5 lần đạt 9.0 IELTS. Nhưng phần lớn thời gian mình lại không dành để luyện đề IELTS. Đều đặn 30 phút mỗi ngày, mình tập trung nghe và đọc nhiều tài liệu tiếng Anh mà mình yêu thích. Với mình, kiến thức ngoại ngữ là vô hạn và 9.0 IELTS cũng chỉ là
And then half of A, or 4 units to the right, and 4 units to the left. So the point is going to be at the origin and 8 units down. The center is 4 units down. So if A is 8, the radius is 1/2 of A, which is 4. So we got to travel 4 units to the right from the center and 4 to the left. And so this is going to be the graph. So now you know how to graph circles when you're given a polar equation. Now the next type of graph that we need to go over is the Limassol. And the equation is r is equal to a plus or minus b sine theta. Now, sign, it opens towards the positive y-axis, that is in the upward direction. Negative sign opens in a downward direction, in a negative y direction. You could also have a plus or minus b cosine theta. So if cosine is positive, it's going to open towards the right in the positive x-axis direction, and if cosine is negative, it's going to open towards the left. So let's draw the general shape if it opens towards the right. So this is the Limassol with the inner loop. And let's draw the direction. You could also have a plus or minus b cosine theta. So if cosine is positive, it's going to open towards the right in the positive x-axis direction, and if cosine is negative, it's going to open towards the left. So let's draw the general shape if it opens towards the right. So this is the Limassol with the inner loop. And you get this particular shape if a divided by b is less than 1. Now both a and b represent positive numbers. A and b are both greater than 0. So if you get the graph 3 minus 4 sine theta, b is not negative 4, b is positive 4, and a is positive 3. So let's say if it was 3 plus 4 cosine theta, both a and b would still be 3 and 4. Positive 3 and positive 4. So a and b are not negative. Now the next shape that we have, if a divided by b is equal to 1, is the heart-shaped Limassol, also known as the cardioid. And here's the generic shape for it. So it has like this dimple. So it looks something like that. Maybe I could draw that better. So that's the cardioid. Now the next one is the dimpled Limassol with no inner loop. So that occurs if a over b is between 1 and 2. So let's start with the x-axis. It's a small dimple. Sometimes it's hard to notice. So that's the dimpled Limassol with no inner loop. The next one we need to know is, so small dimple. So let's start with the x-axis. It's a small dimple. Sometimes it's hard to notice. So That's the dimpled limousin with no inner loop. The next we need to know is if A divided by B is equal to or greater than 2. So this limousin looks almost like a circle, but it's not. There's no dimple and there's no inner loop. So I'm going to start from the left. I'm going to draw it straight up, and then it looks like this. But it's not exactly a circle because, as you can see, the right side is like bigger than the left, but it almost looks like a circle. So that's the limousin without a dimple or an inner loop. So those are the 4 shapes you need to be familiar with. Let's graph this equation. Let's say r is equal to 3 plus 5 cosine. What do you think we need to do here? We know this is a type of limousin. It's in the form a plus or minus b cosine theta. So first, we need to identify a and b. A is equal to 3, and b is equal to 5. Now, we need to see if a over b, if it's less than 1, if it's between 1 and 2, if it's equal to 1, or greater than or equal to 2. So a over b, that's 3 over 5. And 3 over 5 as a decimal is 0.6, which is less than 1. Now, because it's less than 1, we know we have the limousin with the inner loop. Now, there's 4 types. The first type is if it's positive cosine. This graph will open towards the right. The next type is the right if it's positive cosine. This graph will open towards the right. The next type is if we have negative cosine. And in that case, this graph would open towards the left. Is if it's positive cosine. This graph is 4. So A and B are not negative. Now the next shape that we have, if A divided by B with the inner loop.
In this legendary space MMO, the heroic acts and merciless betrayals of its players,
It's the difference between A and direction. And 3 over 5 as a decimal is 0.6, which is less than 1. Now, because it's less than 1, we know we have the limousin with the inner loop. Now, there's 4 types. The first type is if it's positive cosine. This graph will open towards the right. The next type is if we have negative cosine. And in that case, this graph would open towards the left. If it's positive sine, then it's going to open in the positive y direction. And if we have negative sine, it's going to open towards the negative y direction. So it's going to look something like that. So just keep that in mind. That's the first thing that you look for. So we have positive cosine, which means it should open towards the right side. Now, when graphing this type of limousin, you want to make sure you get 4 points two x-intercepts and two y-intercepts. So let's draw a rough sketch of this graph. This
Tôi lớn lên khi đất nước không còn chia Bắc Nam. Chẳng biết chiến tranh là gì, chỉ được nghe trong những câu chuyện của cha. Tôi lớn lên khi tháng tháng không còn lo phiếu tem, không biết bó là gì, chỉ còn lại trong những ký ức của mẹ. Chuyện của cha tôi là những giấc mơ dở dang, là xếp bút nghiền chiến đấu. Tôi lớn lên khi đất nước không còn chia Bắc Nam, chẳng biết chiến tranh là gì, chỉ được nghe trong những câu chuyện của cha. Tôi lớn lên khi tháng tháng không còn lo phiếu tem, không biết bó là gì, chỉ còn lại trong những ký ức của mẹ. Chuyện của cha tôi
là những giấc mơ dở dang, là xếp bút nghiền chiến đấu vì một màu cờ đỏ tươi thấm máu bao người. Chuyện của mẹ tôi là cất tiếng ca cho đời, là đến những nơi xa xôi với những con người cạnh ngôi sao vàng trên phố. Một thời chiến đấu cha tôi anh hùng, một thời gian khó mẹ tôi đảm đang, thì vẫn giữ nụ cười và tiếng hát tiếng bom để rồi đây bước trên con đường đời. Dù bao gian khó trong gai đời tôi, đứng dưới bóng cờ làm con tim ngân lên tiếng ca đoàn quân Việt Nam đi. Đất nước không còn chia Bắc Nam, chẳng biết chiến tranh là gì, chỉ được nghe trong những câu chuyện của cha. Tôi lớn lên khi tháng tháng không còn lo phiếu tem, không biết bo là gì, chỉ còn lại trong những ký ức của mẹ. Chuyện của cha tôi là những giấc mơ dở dang, là xếp bút nghiền chiến đấu vì một màu cờ đỏ tươi thấm máu bao người. Chuyện của mẹ tôi là cất tiếng ca cho đời, là đến những nơi xa xôi với những con người cạnh ngôi sao vàng trên mũ. Một thời chiến đấu cha tôi anh hùng, một thời gian khó mẹ tôi đảm đang, thì vẫn giữ nụ cười và tiếng hát đã tiếng bom để rồi đây bước trên con đường đời. Dù bao gian khó trong gai đời tôi, thì đứng dưới bóng cờ là con tim ngân lên tiếng ca đoàn quân Việt Nam đi. Rồi ngày tháng trôi, bao đời thay đến với cuộc đời, thì trong trái tim tôi luôn tự hào là người Việt Nam. Màu cờ thắm tươi vẫn phấp phới với những cuộc đời lòng bồi hồi. Một thời chiến đấu cha tôi anh hùng, một thời gian khó mẹ tôi đảm đang, vẫn giữ nụ cười và tiếng hát đã tiếng bom để rồi đây bước trên con đường đời. Dù bao gian khó trong gai đời tôi, đứng dưới bóng cờ là con tim ngân lên tiếng ca đoàn quân Việt Nam đi.
The first x-intercept, which is associated with the inner loop, it's the difference between a minus b. So it's the absolute value difference of a minus b. Or you could just say it's b minus a because b is going to be bigger. Now, the second intercept is the sum of a and b. And that's all you need to get a good, decent graph. If you can plot those four intercepts, then it should be fine. So let's go ahead and do that. So in this case, we can see that a is equal to 3. So we need to go up 3 units and down 3 units. You should be fine. So let's go ahead and do that. So in this case, we can see that a is equal to 3. So we need to go up 3 units and down 3 units. So those are the y-intercepts. Now, b minus a, that's going to give us the first intercept. That's 5 minus 3. That's 2. So here's the first intercept. And then 8 plus b, that will give us the second intercept. That's 3 plus 5, which is 8. So that's how you could find the two x-intercepts. Now let's go ahead and graph it. So first, let's start with the inner loop. And then let's go towards the first y-intercept, and then the second x-intercept, and then towards the other y-intercept. So that's a rough sketch of this graph. So the points that you need is 3 and -3 on the y-axis, and 2 and 8 on the x-axis. Let's try another example. So let's say r is equal to 2 minus 5 sine theta. So try this one. The first thing I would keep in mind is in what direction will it open? We know that a over b, which is 2 over 5, it's less than 1, so this is a limacon with an inner loop. But notice that we have a negative sign, so therefore it has to open in a negative y direction. So we can see that a is 2, that's going to give us the y-intercepts, and b is 5. So let's go ahead and graph it. Well, in this case, because it opens downward, a is actually going to be associated with the x-intercepts this time, instead of the y-intercepts. So it's going to switch roles. So we need to travel 2 units to the right. A is actually going to be associated with the x-intercepts this time, instead of the y-intercepts. So it's going to switch roles. So we need to travel 2 units to the right, and 2 to the left. What direction will it? Notice that y a is, if we're dealing with cosine, then a would be associated with the y-intercepts, but because we're dealing with sine, the roles are reversed. Now a plus b, that's going to be 2 plus 5, that's 7. And b minus a, 5 minus 2 is 3. So we're going to travel 3 units down and also 7 units. So we're going to have 2 y-intercepts. So let's start with the inner loop. And then let me do that again. And then let's get the x-intercept.
To save the mesh.
So let's find the value of a over b. A is 3, b is 7. And 3 over 7 is less than 1, because 7 over 7 is... Now, we're dealing with negative cosine, which means the majority of the graph is going to be on the left side. Now, a is associated with the y-intercepts when dealing with cosine. When dealing with sine, as we saw in the last example, a is associated with the x-intercepts. Up, and 3 units down to get the y-intercepts when dealing with cosine. For sine, you need to know that a is associated with the x-intercepts. So next, let's find the first x-intercept, which is going to, and then a plus left, we need to travel 4 units to the left. That's going to give us the first x-intercept. And then 10 units to the left relative to the origin. So that's the second x-intercept. Now let's go ahead and graph it. Because we're plus, which means, example. So what we have is the inner loop limacon. Now, we're dealing with negative cosine, which means it's going to open towards the left. So the majority of the graph is going to be on the example loop. And then let's focus on the outer loop. And so that's it. That's how you can graph it. My graph is not perfect, but at least that's the general shape. You get the picture. That's how you can graph it. My graph is not perfect, but at least that's the general shape. You get the picture. Now let's try this one. Let's say that r is 3 plus 3 cosine theta. What do we need to do here? Well, first, we need to determine what type of limosome we have. A and B are the same. When A and B are the same, A over B is equal to 1. And in that situation, we have the heart-shaped limosome, also known as the cardioid. And because cosine is positive, it's going to open towards the right. Now I'm just going to draw the general shape of the cardioid, which it looks like this. So there is no inner loop. Now when dealing with cosine, the x and y intercepts are going to be a again, a and negative a, be the origin. And so we don't have to do anything, it's just going to start from the origin. Now the second x-intercept is a plus b. We don't have the inner loop, which is going to be 6, 0. So now we're going to have to graph it like this.